So, me caveman, let's go. Number 10. The Hamin Mangha Fire Disaster. Picture a single room, smaller than a modern bedroom, packed with the tangled bodies of nearly 100 people. This is House F40, and it sits at a place called Hamin Mangha, in Horkin left middle banner, in Inner Mongolia, in northeastern China. It is the largest and best preserved prehistoric settlement ever found in that entire region. Radiocarbon dating places it at roughly 5,000 years ago, in the late Neolithic. Archaeologists from the Inner Mongolia Institute of Cultural Relics and from Jilin University excavated it between 2011 and 2012. They uncovered the foundations of dozens of houses, and then they opened F40. The house was a small, semi-subterranean structure, only about 20 square meters in floor area. That is around 210 square feet. Inside, laid out in a disorderly tangle, were the remains of at least 97 human beings. The bodies had been stacked toward the center of the room, one on top of another. When researchers studied the bones, a chilling pattern emerged. Most of the dead were young adults, between 19 and 35 years old. There were very few elderly people. That age profile is the signature of an epidemic, not of a natural death. Above the skeletons sat a compact, dark layer of sediment. That layer is the residue of fire. The burning happened after the bodies were already inside. Some of the skulls and limb bones are charred and heat deformed, which means the flames reach the pile directly. Researchers believe the wooden roof caught fire and collapsed down onto the dead. The bodies themselves had been carried in and stacked one after another. These people did not die inside this room. They were brought here, gathered, and sealed in. The leading interpretation is grim and simple. An acute infectious disease swept through the settlement faster than the living could bury the dead. The house became a repository for bodies, and then it burned. Similar evidence of mass death and abandonment has turned up at nearby sites like Miaozigu. The stacking itself tells us something important. Even as the death toll climbed, social organization held together. Someone was still managing the dead, still carrying bodies into that one small room in a deliberate order. This was a community trying to cope with a catastrophe it could not stop. So what actually killed them? The mainstream answer is epidemic disease. The demographic profile, all those healthy young adults dying together, fits a fast-moving outbreak far better than warfare, famine, or old age. Some archaeologists suggest a combination of disaster and mortuary practice. A fringe view proposes massacre or ritual killing, though the age data argues against a battle. Researchers now study Hamin Mangha as a deep-time case of how small, dense settlements can be shattered by infectious disease, an unsettling echo of our own modern fears. Hold that image of stacked bodies, because the next event asks a stranger question. What happens when the dead are not stacked, but simply gone? Number 9. The Lost Army of Cambyses. 50,000 soldiers marched into the desert and were never seen again. That is the claim, and it has haunted archaeologists for well over a century. The event is dated to around 525 BC, during the first Persian conquest of Egypt. The Persian king was Cambyses II, son of Cyrus the Great. He was the king of kings, and he wanted to be recognized as pharaoh. But the priests of the Oracle of Amun would not give him the legitimacy he demanded. So, according to the Greek historian Herodotus, Cambyses sent an army. Herodotus, in Book 3, Chapter 26 of his Histories, describes a force of 50,000 men marching out from Thebes. Their mission was to destroy the Oracle of Amun at the Siwa Oasis. The soldiers reached roughly halfway across the vast western desert. And then a catastrophic sandstorm buried them completely. Herodotus writes that the men were sitting down to a meal when a violent south wind rose and covered them in drifting sand. Not one of them was ever seen again. This oracle was no minor shrine. It was one of the most prestigious in the ancient world. More than 2 centuries later, Alexander the Great would journey to that same oracle at Siwa to be hailed as a son of Amun, so the stakes of destroying it were enormous. Yet many Egyptologists regard the whole story as apocryphal. The number 50,000 is a classic Herodotian round figure, and modern historians treat it with caution. We do know Cambyses waged a real and successful campaign. He defeated the pharaoh Psamtik III at Pelusium in 525 BC, and he captured Memphis. The Siwa expedition, if it happened, would have branched off from that victory into the deep desert. In 2009, 2 Italian researchers, the twin brothers Angelo and Alfredo Castiglione, announced they had found bronze weapons, a silver bracelet, an earring, and hundreds of human bones near Siwa. They linked these to the lost army. But the claim drew heavy criticism. The finds came from no controlled excavation, and the announcement was tied to a documentary. Egypt's Antiquities Authority publicly dismissed it. So what really happened? Perhaps the army was much smaller. Perhaps it was defeated by local Libyans, or simply deserted. Perhaps Cambyses, notorious in Greek sources for madness and sacrilege, attracted a legend designed to blacken his name. Or perhaps 50,000 men really do lie somewhere beneath the dunes, waiting. The problem is the desert itself. Shifting sands can move and recover terrain over thousands of years, which makes any buried army almost impossible to locate systematically. Modern desert archaeology now uses satellite imagery and ground-penetrating radar in the search, yet no verified mass grave of Persian soldiers has ever been confirmed. The story endures as the archetype of an army swallowed whole by nature, a caution about waging war against the desert. From an army swallowed by sand, we turn to something buried under Europe itself. Number 8. The Laacher See Eruption. There is a supervolcano in Germany, and almost no one is taught about it. It hides in plain sight as a calm and scenic lake called Laacher See in the East Eifel volcanic field of western Germany, not far from Koblenz. Around 13,000 years ago, it erupted with staggering violence. For decades, that classic date stood at roughly 13,000 years before the present. Then, recent tree ring work refined it, and one correction placed the true age closer to 12,880 years ago, about 130 years off the earlier estimate. The scale is hard to grasp. The eruption rated a volcanic explosivity index of 6, with a magnitude of about 6.2. It expelled roughly 6.3 cubic kilometers of a rock called phonolithic tephra. The eruption column rose at least 20 kilometers into the sky. To put that in modern terms, this blast was around 250 times larger than the eruption of Mount St. Helens in 1980. Pyroclastic flows devastated the landscape around the vent. Ashfall spread across Europe, from the Alps in the south to the Baltic in the north. That ash layer matters far beyond the destruction. Geologists call it the Laacher See tephra, and it is a key marker horizon buried in lakes and bogs all across Central Europe. When you find that layer, you know the exact moment in time you are looking at. The eruption also did something remarkable to the landscape. Debris dammed the river Rhine, creating a temporary lake. When that natural dam finally burst, it sent a great flood surging downstream. The timing is intriguing. The eruption happened during a warm phase near the end of the last ice age, called the Aller-Rud interstadial. That moment sits very close to the onset of the Younger Dryas, a sudden return to cold. Some researchers have wondered whether the eruption helped trigger that cold snap. The honest answer is that a firm causal link has not been established. What we do know is that late Paleolithic people of the Federmesser culture lived in the region and would have witnessed the catastrophe and fled. Archaeologists even study how the falling ash both destroyed and preserved their Stone Age sites, freezing a moment of prehistoric life beneath a blanket of tephra. The volcano is not dead. It is only sleeping. Volcanic carbon dioxide still bubbles up along the lake's shore, in features called moffetts. The East Eifel field is classified as potentially active. Scientists have even run simulations of a modern eruption of this size, modeling how the ash would cripple European air travel and agriculture. So this is a benchmark for what a large European eruption would do to us today. And yet, for all its power, the Laacher See Eruption killed nothing like the number that our next event did, because the next killer needed no fire at all. Number 7. The Plague of Athens. In the year 430 BC, a disease entered the greatest city in Greece and began to take it apart. It struck in the second year of the Peloponnesian War against Sparta, and it returned in waves through about 426 BC. Timing made it worse. Under the strategy of the statesman Pericles, the rural population had crowded inside the long walls of Athens to avoid open battle. That density turned the city into a perfect engine for contagion. We know this outbreak in vivid detail because of one man. The historian Thucydides caught the disease himself, survived, and left the earliest detailed clinical description of an epidemic in Western literature. His symptoms read like a nightmare. Victims suffered a burning fever, inflamed and bloodshot eyes, and a bloody, ulcerated throat. The illness moved into the chest with violent coughing. Then came vomiting, retching, convulsions, and a thirst that could not be quenched. Sufferers were seized by such internal heat that they tore off their clothing and threw themselves into cisterns and fountains. Those who survived often lost their fingers, their toes, their eyesight, or their memory. Death typically came on the 7th to 9th day. The toll was catastrophic. Estimates run from 75,000 to 100,000 dead, on the order of a quarter to a third of the entire population. And it took the city's leader. Pericles, the architect of Athens' golden age, died of the plague in 429 BC. Thucydides describes something even more disturbing than the physical horror. Society itself broke down. The dying lay unburied. Temples filled with corpses. Traditional funeral rites collapsed, and people abandoned law and religion, believing they were already condemned. Physicians died at high rates because they attended the sick, and no remedy worked. Here's the strangest part. We still do not know what the disease was. The pathogen remains unidentified and hotly debated. Candidates include typhus, smallpox, typhoid fever, measles, bubonic plague, and even a viral hemorrhagic fever. In 2006, a study of dental pulp from a mass burial pit near the Kerameikos Cemetery reported DNA consistent with typhoid fever. But that result is disputed and has not been universally accepted. The Kerameikos grave itself held around 150 bodies, buried in haste and disorder, exactly matching Thucydides' picture of a city overwhelmed. Later writers echoed the account. Diodorus Siculus attributed the outbreak to overcrowding and to a contagion imported through the busy port of Piraeus, possibly from Egypt or Ethiopia. The plague also blunted Athenian military power and morale at a pivotal moment, and many historians argue it helped shift the long war's balance towards Sparta. Thucydides recorded the symptoms so precisely, he said, so that the disease might be recognized if it ever came again. It is one of the earliest acts of clinical documentation for the sake of posterity. From a plague that erased a third of a city, we move to a disaster that erased an entire green world. Number 6. The collapse of the Green Sahara. The largest desert on Earth was once a garden. For thousands of years, the Sahara was not sand, but grassland, dotted with lakes and rivers and teeming with wildlife. Scientists call this era The African Humid Period. It ran from roughly 11,000 to 5,000 years ago, and it peaked between about 9,000 and 6,000 years ago. The cause was written in the sky. Earth's slow axial wobble, called precession, increased the strength of summer sunlight in the northern hemisphere. That strengthened the African monsoon. The numbers are dramatic. Climate models show that a 7% increase in summer radiation, similar to what happened during the African Humid Period, produces at least a 17% increase in monsoon rainfall, and up to 50% once ocean feedbacks are included. The evidence of that lost world survives on stone. Rock art at sites like Tassili N'Ajjer depicts cattle, hippos, crocodiles, and even human beings swimming. Lake Megachad, the ancestor of today's shrunken Lake Chad, swelled into one of the largest lakes on the entire planet. People herded cattle, fished, and buried their dead at sites such as Gobero in Niger. And then it died. The African Humid Period ended near 5,000 years ago as precession reversed and the monsoon rains retreated southward. The scientist Peter de Monocle, studying dust blown out over the Atlantic and captured in marine sediments, documented the timing of that drying. But the record holds a warning. In some regions, the land dried far faster than orbital changes alone can explain. The reason appears to be a feedback loop. As the plants died, the bare ground grew brighter and reflected more sunlight back into space. That suppressed rainfall even further, which killed more plants. The desert fed on itself. Some researchers argue that humans helped tip the balance, that overgrazing by early herders accelerated the collapse. That is the humans as agents hypothesis. Whatever the exact cause, the consequence reshaped history. As the land dried, people were driven to concentrate along the one reliable source of water, the Nile Valley. Many scholars link that environmental refugee movement directly to the rise of Egyptian civilization around 3100 BC. Think about that. One of humanity's greatest civilizations may have been born out of a climate catastrophe. The Green World became a 9 million square kilometer barrier of sand, and this was not the only time drought toppled a civilization. The next event did it to 3 at once. Number 5. The 4.2 kiloyear event. Around 4,200 years ago, the sky stopped giving rain to much of the world, and the first empires of humankind fell almost together. This was a severe, prolonged megadrought that began around 2200 BC and likely lasted much of the 22nd century BC. It ranks among the most severe climate events of the entire Holocene. It is so significant that geologists used it to define the start of a whole new age, the Megalayan Age, marked in a stalagmite from Mamlu Cave in India. We read this drought in cave formations, lake sediments, ice cores, and ocean floor mud. The proxies all tell the same story. Monsoon systems weakened and rainfall collapsed for somewhere between 100 and 300 years. And where the rain failed, the empires failed with it. The event is linked to the collapse of the Akkadian Empire of Mesopotamia, the world's first true empire, founded by Sargon of Akkad. The archaeologist Harvey Weiss, digging at Tel Leilan in northern Syria, found the city abruptly abandoned around 2200 BC, sealed beneath a sterile layer of windblown dust. A Mesopotamian text called the Curse of Akkad even blames the empire's fall on divine abandonment and famine. The reach was continental. In Egypt, the same drought is associated with the fall of the Old Kingdom and the chaos of the First Intermediate Period. Low Nile floods appear in Egyptian records. The tomb autobiography of a governor named Anktifi describes famine so severe that people were driven to cannibalism. Far to the east, the great cities of the Indus Valley, like Mohenjo-Daro and Harappa, began to empty as their monsoon-fed rivers weakened. Early Bronze Age settlements across Anatolia, the Aegean, and the Levant declined in the same window. Because this drought struck Mesopotamia, Egypt, and South Asia almost simultaneously, It is a candidate for the first truly global, climate-driven collapse of human societies. Why were these states so fragile? Because they were centralized and dependent on irrigation. Their surplus-based bureaucracies could not absorb decades of failed harvests. Sediment cores from the Gulf of Oman even preserve a spike of dust blown off Mesopotamian soils around 4,200 years ago, a chemical fingerprint of the drying. The proposed climate mechanisms include shifts in the North Atlantic Oscillation and in sea surface temperature patterns that suppressed rainfall for generations. The naming of the Megalayan Age by the International Commission on Stratigraphy in 2018 formally recognized just how deep a mark this drought left in the global rock record. Some scholars caution that the event was not perfectly synchronous everywhere, and that politics compounded the climate stress. But the pattern is clear. When the rain stops, civilizations end. And when the water comes instead of leaving, the result can be just as deadly. Number 4. The Black Sea Deluge. What if the story of Noah's flood is the memory of a real catastrophe? In 1997, two geologists from Columbia University, William Ryan and Walter Pittman, proposed exactly that. Their idea is called the Black Sea Deluge hypothesis. They suggested that around 7,600 years ago, roughly 5,600 BC, the Mediterranean Sea catastrophically broke through the Bosphorus and flooded the Black Sea. Here is the setup. Before the flood, the Black Sea was not a sea at all. It was a lower-lying freshwater or brackish lake, its surface sitting well below the level of the world ocean. As the last ice age ended, global sea levels rose. Eventually, the rising Mediterranean overtopped the rocky sill of the Bosphorus and began to cut a channel. Then it unleashed. Ryan and Pittman estimated the inflow submerged more than 100,000 square kilometers of coastal shelf. Water levels rose by more than 100 meters, and by some accounts, this happened in under a year. The discharge dwarfed Niagara Falls, carving the Bosphorus as it roared through. The evidence is written in shells and sediment. Sediment cores show an abrupt appearance of salt-tolerant Mediterranean mollusks, lying directly on top of freshwater shells. The dates of those marine mollusks cluster around 7,150 radiocarbon years before the present. High-resolution seismic surveys revealed drowned river valleys, carved by rivers like the Dnieper and the Don, running across the shelf at depths of 90 to 140 meters. That land was once dry and above water. In 1999 and 2000, the ocean explorer Robert Ballard dove into the Black Sea and found an ancient submerged shoreline, along with signs of human habitation beneath the waves. Ryan and Pittman made the boldest connection of all. They linked the flood to humanity's flood myths, including the Epic of Gilgamesh and the story of Noah, suggesting a deep time memory of a real inundation. But the hypothesis is fiercely contested. Critics argue for a gradual, two-way exchange of water rather than a single catastrophic flood. Some evidence suggests the Black Sea was reconnecting earlier and more slowly than the catastrophe model requires. The debate is really about tempo. Was it a wall of water in a single year, or a steady rise over centuries? Even the skeptics agree the lake became a sea. The Black Sea's deep water is anoxic, entirely without oxygen, and that makes it one of the finest preservation environments on Earth. It has already yielded astonishingly intact ancient shipwrecks. So, drowned Neolithic villages may still lie perfectly preserved on that flooded shelf, waiting to be found. Now, we turn from a flood that may have drowned villages to an event that erased the giants of the Earth. Number 3. The Quaternary Megafauna Extinction. This may be the first great slaughter in which our own species stands accused. Between roughly 50,000 and 10,000 years ago, a wave of extinctions erased much of the world's megafauna, the term for animals over about 44 kilograms. The list of the dead is staggering. Woolly mammoths, mastodons, giant ground sloths, armored glyptodonts the size of cars, saber-toothed cats, the giant deer known as the Irish elk, in Australia, the enormous marsupial Diprotodon. And here is the pattern that damns us. The extinctions were staggered continent by continent, and they tracked the arrival of human beings with unsettling precision. Australia lost most of its giant marsupials around 45,000 to 40,000 years ago, near the time humans arrived. The Americas lost dozens of megafauna genera around 13,000 to 11,000 years ago, roughly when humans spread through the two continents. In the mid-1960s, the scientist Paul Martin of the University of Arizona proposed the overkill hypothesis. Humans, armed with specialized hunting technology, drove the megafauna to extinction as they spread across the globe. His blitzkrieg version had extinction following human arrival within just centuries. What is the evidence? Kill sites preserve the skeletons of mammoths and mastodons with stone projectile points embedded in the bone. Animals that had never encountered humans would have been naive and easy to approach. But the single strongest argument comes from islands. Woolly mammoths survived on remote Wrangel Island until about 4,000 years ago, thousands of years after they had vanished from the mainland. They died out only after humans finally reached the island. Ground sloths survived on Caribbean islands long after their mainland cousins were gone, again correlating with the later arrival of people. A test published in the Proceedings of the National Academy of Sciences in 2015, using radiocarbon dates, found the timing broadly consistent with Martin's predictions. But there is a powerful counter-argument. Many researchers point to abrupt climate and vegetation change at the end of the last ice age. A study in 2021 found that in North America, declining global temperature correlated with megafauna decline better than human population growth did. So today, many scientists favor a synergy. Climate change stressed these populations, and human hunting delivered the final blow, with the balance differing by species and region. Notice that Africa kept far more of its megafauna, its elephants and rhinos and hippos, perhaps because those animals evolved alongside humans and learned to fear us. The loss reshaped whole ecosystems. These giants were ecosystem engineers. They dispersed seeds, cycled nutrients, and trampled back the forest to keep the land open. When they vanished, the productive mammoth steppe degraded into less productive tundra and forest. That is why some scientists today dream of restoring such landscapes, even proposing to bring back mammoth-like animals to rewild the far north. The extinction is now widely framed as the first great human-driven extinction wave, a deep time precedent constantly invoked in debates over the modern sixth extinction. Whatever ended the giants, our next event nearly ended us. Number 2. The 536 AD Volcanic Winter. Some historians call it the worst year in human history to be alive. In the year 536 AD, a mysterious veil of dust dimmed the sun across Europe, the Middle East, and parts of Asia. The darkness lasted, day and night, for around 18 months. The Byzantine historian Procopius wrote that the sun gave forth its light without brightness, like the moon, and that people were filled with fear. He was not alone. Other writers of the time, including Cassiodorus, John of Ephesus, and Michael the Syrian, independently recorded the dimmed sun, the cold summers, and the failing harvests. This was among the most severe episodes of cooling in the Northern Hemisphere in the last 2,000 years. Summer temperatures dropped an estimated 1.5 to 2.5 degrees Celsius. It initiated the coldest decade in roughly 2,300 years. Tree rings across the hemisphere show sharply suppressed growth beginning in 536, a fingerprint of a cold and sunless season. For a long time, the cause was a mystery. Then, in 2018, a team led by the historian Michael McCormick and the glaciologist Paul Majewski analyzed an ice core from the Colli Gneffeti Glacier in the Swiss Alps. They pointed to a cataclysmic volcanic eruption in Iceland early in 536. The ice remembers. Cores from Greenland and Antarctica record massive sulfate deposits from this period, the chemical signature of major eruptions. And it was not just one eruption. More large eruptions followed in 540 and 547, compounding the catastrophe. The volcanic aerosols reflected sunlight away from the Earth, and the result was famine and failed crops across continents. McCormick called 536 the beginning of one of the worst periods to be alive, if not the worst year itself. The disaster did not end quickly. It helped launch the late antique Little Ice Age, a cold phase that lasted from around 536 to 660. And then, in 541 and 542, came the Plague of Justinian, one of the deadliest pandemics in history. Some scholars connect the climate shock, the famine, and the social stress to the sheer severity of that plague. Famines were recorded from Ireland all the way to China, where records note summer frost and snow falling in August. The scholar Antti Arjava compiled the documentary evidence for this dust veil across the Mediterranean world. The prolonged cold and famine are argued to have driven political upheaval right across Eurasia, adding pressure on the Eastern Roman Empire at its most vulnerable. It stands as the clearest proof in history that a single eruption can bend the climate of the whole planet within a single year, and it remains central to how scientists model the worst-case volcanic risks we still face today. But even 536 is small beside the event at the top of our countdown. Number 1. The Toba Supereruption. Around 74,000 years ago, a volcano in Sumatra may have come within a breath of ending the human species. This is the youngest Toba tuff eruption, at the site of present-day Lake Toba in Indonesia during the late Pleistocene. It is one of the largest known explosive eruptions in the entire history of the Earth, rated a volcanic explosivity index of 8, the level we call a supereruption. It ejected on the order of 2,800 cubic kilometers of dense rock magma. The collapse that followed formed the modern Lake Toba caldera, a hole about 100 kilometers long and 30 wide, the largest Quaternary caldera on the planet. The physical footprint is almost beyond imagining. Pyroclastic flows filled valleys up to 600 meters deep near the vent. Ash blanketed South Asia and the Indian Ocean. In central India, layers of Toba ash up to 6 meters thick still lie in the ground. That ash is now precious to science, because it is a global time marker. When archaeologists find it, they can date a site to before or after that single moment 74,000 years ago. Then comes the theory that made Toba famous. In 1998, the anthropologist Stanley Ambrose advanced what is called the Toba catastrophe theory. He proposed that the eruption caused a severe global volcanic winter lasting 6 to 10 years, followed by a cooling that stretched 1,000 years. And he linked it to a human genetic bottleneck, a moment when the human population may have crashed to as few as 3,000 to 10,000 individuals. If true, it would mean that every living human being descends from the small band that survived Toba's aftermath. It is a breathtaking, terrifying idea. But here is the twist. The newer evidence increasingly says it may not be true. Archaeological sites tell a story of survival. At Pinnacle Point in South Africa and at Daba in India, human activity continues right across the Toba ash layer, with no sign of local extinction. A major analysis argued that the eruption's environmental impact on early humans has been overestimated. Refined climate models suggest that while much of the northern hemisphere may have cooled by about 4 degrees Celsius, most of the southern hemisphere saw little to no cooling at all. And crucially, numerous genetic analyses have failed to detect any bottleneck that lines up with the Toba eruption. The paleoanthropologist John Hawkes has argued bluntly that the so-called Toba bottleneck simply did not happen. Marine records have also revealed that Toba erupted in multiple phases, which complicates any tidy single catastrophe narrative. The emerging consensus leans toward human resilience rather than near extinction. Toba remains the definitive example of supervolcano risk, and studying it informs how scientists assess other sleeping giants like Yellowstone. So the darkest event on our list carries the strangest lesson of all. Humanity faced the largest eruption in its history and walked out the other side. Step back from the countdown, and the 10 events begin to sort themselves into 3 dark shapes. The first is sudden mass death. The stacked bodies of Hamin Mangha and the corpse-filled streets of Athens belong here. The second is vanishing, disappearance without a trace, embodied by the 50,000 soldiers of Cambyses swallowed by the desert. The third is slow collapse, the kind of drawn-out catastrophe seen in the drying of the Green Sahara and the megadrought of the 4.2 kiloyear event. Why do textbooks tend to skip them? Part of it is discomfort. Mass graves, references to cannibalism, and the idea of our own near extinction resist tidy classroom framing. Many of these events have no clear hero and no clean moral. They are indifferent catastrophes. Several are still contested science, and schools are reluctant to teach as settled fact, something researchers are still arguing over, and the scale simply defeats intuition. 50,000 men gone, a third of a great city dead, humanity possibly reduced to a few thousand. Yet look at the reach of this list. It spans from 74,000 years ago at Toba all the way to 536 AD. It crosses every inhabited continent, which tells us that catastrophe is universal, not the misfortune of one unlucky place. In most of these stories, nature is the antagonist, striking through volcanoes, droughts, floods, and disease. In the one case where humans are the likely killer, the megafauna, the story implicates our whole species. Each event left behind a physical archive, in bones or ash or sediment or tree rings. And each one, however dark, reshaped the human story. Some even created civilizations, as the drying Sahara helped birth Egypt. The discomfort is exactly the point. These events teach that survival was never guaranteed. But how do we actually know any of this happened? The dark past is legible only because the Earth keeps meticulous records, and a small toolkit of sciences knows how to read them. Ice cores drilled from Greenland and Antarctica trap the sulfate spikes of ancient eruptions. Those frozen layers let researchers date and even size volcanic blasts that history never recorded, which is exactly how the eruption behind 536 was pinned down. Tree rings preserve the memory of cold, sunless years as narrow bands of growth, and the science of dendrochronology can cross-date those rings to an exact calendar year. Radiocarbon dating fixes the age of anything once alive, from the charred bones of Hamin Mangha to the mollusk shells of the Black Sea to the megafauna kill sites. Cave formations called Speleothems archive rainfall in their layered stone, which is how the 4.2 kiloyear event was marked in Mamlu Cave. Marine sediment cores capture pulses of wind-blown dust, the very records Peter Domenical used to time the drying of the Sahara, and the same records that preserved the dust spike in the Gulf of Oman. Ancient DNA, extracted from dental pulp, can even hunt for the pathogen in a plague, as the disputed typhoid signal from Keramikos shows. Tephra layers, like the Laacher See Tephra and the Toba ash, act as time markers stretched across whole continents. Seismic surveys image drowned river valleys hidden beneath the Black Sea. Osteology, the study of bones, reads age and stress and cause of death, which is how we know the dead of Hamin Mangha were mostly young. Climate models then test whether a proposed cause could actually produce the observed effect, as when researchers mapped Toba's uneven cooling. The real power comes from convergence. We trust the story of 536 because tree rings, ice cores, and written chronicles all agree. But every proxy has its error bars, which is why dates get revised, and why the disagreements fuel the debates that keep these events alive. Read the countdown again, and a hidden hand appears behind half of it. That hand is climate. Volcanic winters recur again and again at Laacher See in 536 and at Toba. The mechanism is identical at every scale. Aerosols hurled into the high atmosphere reflect sunlight, and the surface of the Earth cools. Bigger eruptions inject more sulfate, higher up, and the cooling lasts longer. The year 536 shows that a single eruption can bend a continent's climate within a year. Toba shows the terrifying ceiling of that same process. Megadroughts form a second thread. The collapse of the Green Sahara and the 4.2 kiloyear event both trace back to shifts in monsoon strength and the position of rainfall belts. Orbital precession sets the slow background rhythm of wet and dry over thousands of years. But feedbacks, like the vegetation and albedo loop in the Sahara, or changes in ocean temperature, can accelerate a slow trend into a sudden collapse. Floods complete the picture. The Black Sea Deluge came as sea levels rebounded at the end of the Ice Age, and that same deglaciation underlies the Laacher See Eruption and the Megafauna extinction too. Notice how the victims were chosen. Complex, centralized, irrigation-based societies proved the most brittle, which is why Akkad and the Egyptian Old Kingdom fell hardest. Climate rarely acted alone. It stressed a system until some other pressure finished it off. The Plague of Justinian rode in behind the famine of 536. Drought refugees reshaped entire regions and chained one event to the next. The unsettling part is that the very same forcings operate today. Volcanic risk, drought, and sea level rise have not gone anywhere. These deep-time events are the calibration marks for the worst cases modern science must plan for. The hidden hand was never fate. It was physics, in the form of sunlight, rainfall, and ice. For all our tools, the honest answer to many of these mysteries is that we are still finding out. Toba poses the biggest question of all. Was there truly a human near-extinction bottleneck, or none at all? The genetic and archaeological evidence increasingly says the bottleneck did not happen the way it was first described. The lost army of Cambyses poses a different kind of question. Did it even exist? And if it did, where are the 50,000? No controlled excavation has ever confirmed a Persian mass grave in the western desert. The Black Sea Deluge remains split down the middle. Was it a single catastrophic wall of water, or centuries of gradual rise? The Plague of Athens still hides its killer. Was it typhoid, typhus, smallpox, or some pathogen that no longer exists? The typhoid DNA from Keramakos has not been confirmed by independent teams. Even Hamin Mangha keeps it secret. We believe it was an epidemic, but we do not know which disease killed so many so fast. The Megafauna extinction refuses to resolve into a single cause, and the balance between human hunting and climate shift still shifts from species to species. The questions go on. Did Laacher See help trigger the Younger Dryas cold snap, or did it merely coincide with it? Was the 4.2 kiloyear event truly synchronous across the globe, or a cluster of separate regional droughts? Which volcano fired the first shot in 536? And how tightly did that climate shock drive the severity of the Plague of Justinian? Dating precision limits many of these answers, and a revision like the one that moved Laacher See by 130 years can shift whole timelines. Preservation bias means we mostly find what happened to survive, not everything that was lost. But new genome techniques may finally settle the plague and bottleneck debates, and underwater archaeology in the Black Sea could yet reveal drowned Neolithic villages. Each unknown is a frontier, not a dead end. Across 74,000 years, one pattern holds above all others. Catastrophe is the rule, not the exception. Our species has already survived a supereruption, a green continent turning to sand, and the world's first empires dissolving in drought. The darkest events on this list are also, quietly, proof of our endurance. We are the descendants of the ones who lived through them. Even the near-extinction story of Toba, if it were true, ended not in oblivion, but in recovery and expansion. Look closer, and disaster and creation turn out to be entangled. The refugees of the drying Sahara did not merely survive. They gathered along the Nile and helped build one of the greatest civilizations the world has ever known. Collapse in one place seeded a rise in another. These events dwarf a single human lifespan, which is precisely why they slip out of memory. And yet the earth remembers them in ice and stone and ring and bone. To study them is to inherit both a warning and a reassurance at the same time. The warning is real. Complex societies are fragile against climate operating on a scale we rarely imagine. But the reassurance is just as real. Our species has walked out of every catastrophe so far. The difference now is knowledge. We can model supervolcanoes, track droughts as they form, and read sea level rise before it arrives. That foresight is the one defense our ancestors never had. So the events too dark to teach turn out to be exactly the ones most worth teaching. They replace the comfortable myth of steady progress with the truer and stronger story of survival against the odds. Every person watching descends from people who endured at least one of these disasters. The countdown ends not in despair, but in perspective. We are a resilient, catastrophe-tested species, and the darkest chapters of the past are the clearest map we have for the ones still ahead.